He has to set it up a little bit for the webinar. But thanks for everyone for the patience that you guys have shown, and thanks for attending the session today. The webinar topic is using R and Roheb. He has, statistical modeling as well as data science, and he's adept at multiple tools. And so he's actually, as we call them, as a true data scientist because he has worked across variety of tools as well as domains within data science. So he'll walk us through some of the important things within data science using R today. And feel free to ask questions unless you have a very important question. Please type in your question on the chat window, and Shoaib will try to address those questions as he deem feel important. Okay, Shoaib, over to you.
Okay. Thanks, Pratik. Thanks for the introduction as well. That was very nice. So I'm still trying to get everything loaded up. I had everything loaded up on my laptop, but we are not able to use it. So I'm still loading. Loading up all the pages that we would use for the present. So I have because I need to get one of the. I have the agenda text file open, and which gives you like an overview of what we're going to discuss today. So I would like to start with agenda, and then probably we'll move to and then we'll move on to the core topic for the webinar, that is data manipulation case study using the airline tweets dataset. I'll walk you through the entire the whole process, the entire steps. So just taking you through the overview, and finally we'll finish it up with the same dataset. So if based on the information that was
Sure. Just one quick suggestion. Can we zoom in a little bit or increase the font on the screen?
Okay. But just talk about just to make sure that I don't miss out anything, right? New to R. So just to get R on the Windows platform right now, and you can see that on the screen. You can actually download the code and actually follow along while we discuss. So the prerequisite, or rather the software requirements for that, is project website. And I'm not sure how many of you are actually planning to follow. Questions, quick couple of questions. How many of you actually familiar with minimum familiarity with R, so you could actually you already have R set up on the Git repository? Okay, all right. So you can do it on your side, still listening to the session, and if you can get everything ready, you could always catch up. So
yeah,
thing is,
get a recording of it as well.
I think I'll just take you through quickly through that as well. So look for our project, and this takes you to the first page. So this is the main page, www.r-project.org, and from here you can just directly go to the download R link, and it takes you to a set of mirrors. You just choose the first one, and which takes you to the download page. And based on the OS that you're using, go for your Mac OS X version, and it should, and you can just install. Click on the base version, and that should take you to the download page, actual download page. It's around 62 MB, and it has both 32 and 64-bit. I already have R installed on my machine. Okay, so you can start downloading this on your side. And the next thing is the preferred IDE to work with R, which is the R Studio. And this is also pretty easy to install for RStudio, and the first link is always the main page. Download RStudio. I mean, just let me know. I can slow down a bit. So download the RStudio desktop, and first install your R. And when you so this is the RStudio tool or the IDE that that I'm using for working with R. Next thing that you really need is this code. Okay, I'm thinking that you get github.com/airline dash. This is the GitHub page that you need to join. So you load this up, and you have you can actually download a copy. This repository loaded up. You can just click on. Now, if you think that's much for you to forever, you can always come back and download a copy of it and start working with it whenever you can. Okay, so it's not necessary. So don't panic if it's not working out for you. If I'm going too fast and you're not really getting a grip over, how any of these things work. So it's fine. All right, so I think that takes care of the logistics part of the webinar, because this is usually the thing which takes a bit of time. All right, so okay, I think there's a request for summing up the steps. Fine. First thing, just Google for R project. And the first link that you get is basically the R project website. From there, navigate to the download page and download the latest version for your preferred platform. So I'm guessing most of you use Windows, so it should be Windows. All right. So download the base version and install it. It's around 62 MB. All right. Do not worry about 32-bit, 64-bit confusions, because it installs both 32 and 64-bit versions, so it shouldn't really matter. Step number 2, so you have your R installed, and now you need your IDE to work with it, right? So the preferred one is RStudio. I'm not saying this is the only one out there. There are others, but this is the preferred one. Now you can always go ahead and Google for RStudio, and the first link that shows up is the RStudio main page. From there, you can choose RStudio desktop, and the one that you need to download is RStudio desktop, the open source version. But if you wanna pay for it, I'm not gonna stop you. But to start with, RStudio desktop is more than enough. All right. So that's the second thing. Third thing, you need the code, right? I mean, code that we used with the webinar today. So that is sitting in my GitHub page. So that is the link is right here. In case if you guys need me to send this or share this with you over email or something, that's possible. Yes. So, but just that you, if you're listening. Okay, all right. Why didn't I think of that? All right, I'm going to share it here, so it's easier for you guys to access it. So there it is. That is the page. It is a public repository, so anyone is free to access it and download a copy of it. And you can once you load up that page, just click on clone or download, and you can either, if you know how to use Git, you can always clone it, or just go for the download zip. So that'll download a zip file which will have this sentiment.r code. So this is the code that we would use for today. All right. Okay. Now I hope it's clear. How to set up R and get access to the code. Fine. So I am going to take, let's say, around 10 minutes to talk about, to give you a general introduction to R, and why we should be excited about, this software and tool. I am excited. This is basically my favorite data analysis tool, and I want to share the reasons why I am very excited about this tool. So it'll take around like 10 to, close to 10 minutes. By the time we actually start the intro to our environment section. So if you want to do the installation part on the side, you're free to do that. Okay, so a little bit of history to start with. So R started off as an open source version of something called S or S+. Okay. Now this was a paid software, and there was a movement which resulted in an open source version of that S+ software, and R is basically for to actually to work. And it was, from its initial days, it was primarily, things have changed now, primarily used in the academia when during its initial years. And the reason for its popularity within academia was that it was free. It was free to use. It was you can always use. Now, and so the free part was really important. And okay, all right. So pretty. So it till about So it's but if you look at it currently, it is one of the fast. Okay, there was phenomenal art software within the industry in the last 5 years, and I've seen let's say 6 years back, nobody used to put R as a requirement in their job profiles, and from there currently it's R makes a mention in any such profiles. Now that is a phenomenal change, and this happened in a really small time window. That's initially the one here was the open, still there. It hasn't gone anywhere. That is your who's always working really hard to bring out new versions, improved versions every now and then. And there was another version called Revolution Analytics. Now I think you can give Revolution Analytics the credit when it comes to accelerating the. Okay, all right, good to know that. Accelerating or giving R that initial momentum that it needed to actually get adopted within the industry. So Revolution Analytics actually gave that push that R needed, because it was getting stuck as an academic software, and it had that free open source tag on it, and people from the industry didn't want to touch it. And that changed when that all that changed when Revolution Analytics, the enterprise, where they that changed everything. So I think they should be given the credit for actually making that industry adoption possible for R. That was a few years back. Milestone, okay, R milestone very recently with the adoption of R. They bought or they acquired the Revolution Analytics company, and now 16. It's been a really great year for software, because we saw that Microsoft has really started putting a lot of effort into making R, really important within the data science space. They've already come out with 3 products which has R integrated with it now. Basically you can write residing on your database, which is really cool. Visualization BI tool that also has one question: SAS R, which is more useful? Okay, it's still the market, the market share king, if you look at it. But which is why I didn't I only spoke about this is the fast. R has the fastest adoption rate. R is catching up, but SAS is still the king when it comes to market share. And I'm pretty sure it's not going to change much, anytime soon, because SaaS has its traditional industries. If you look at it, it has this pharma, drug discovery, banking, insurance, and all that. They're not going to change from SaaS anytime soon. It's going to be it's going to take time, because convincing these people from these industries to shift to R, that's going to take a while. But it's going to happen eventually. Yes. So my answer to your question would be it's not really I wouldn't really go ahead and compare it, but because both these softwares are very much relevant, and it's actually good if you could use you can actually use both. I think I missed one of the questions. Can I come back to these questions? They flash on my screen, but I miss it. Okay, all right. Now, fine. Okay, so one last point, which is Microsoft. The Microsoft version of R is also two types now. There are actually two different types now. This is really new. I mean, it's not something that Microsoft is famous for, but Microsoft is happily making the Microsoft R versions open. So basically, there are two types. One is open, the other one's enterprise. So they are freely giving away their open version as well. So this is phenomenal change on the side of Microsoft as well. As a software vendor, they don't normally do this, but I think they want to give back, because R in its core is still open source, and they still want to keep it open source. I think they're trying to keep that the essence of R in its purest form, that is open source. So let me just quickly show you some links, because I think. So if you just go and search for Microsoft R open, Microsoft R, you'll get the first page, which is MRAN, the Microsoft open page. You go ahead and check it out. So this is where you can actually get a copy of your Microsoft R open. So like I said, this has some bells and whistles fitted into it. It has some math libraries which will make your matrix operations really fast. I am actually running, Microsoft R on this machine. Okay, this is my Windows machine, so I have, Microsoft R open set up, but it doesn't have to be Windows all the time. I mean, there is, Microsoft R open is available for Linux as well. All right. Okay, so coming back again. Okay, so now I want to, go ahead and actually define R. So this is basically my definition for R. You can find very different definitions on the internet, but this is how I like to define it. So R is a statistical software which provides an environment which is coupled with a programming language for end-to-end data-related tasks. Okay, so let me break it down for you. It is a statistical software, yes. Okay, and it provides an environment within which you can bring in your data, manipulate it, you can build models on it, you can visualize that data, and you're doing all this within that environment. Okay, so it provides you that environment. So how do you work with the data which is present in that environment? It gives you a fully functional programming language for that. Okay, now a lot of people talk about a learning curve for R. That has more to do with the nature of the programming language that it uses. Okay. But it makes it so this combination makes it possible for end-to-end data-related tasks. So what do I mean by end-to-end? It means from, let's say, from scraping some data from web pages, accessing data from databases, like accessing data from spreadsheets, bringing it in, doing complex data manipulation, building complex models, visualizing your data, building interactive charts and plots, creating reports, all this in one place. Okay. Now this is sort of a area where R can give SAS some tough competition. All right. Okay. So that is R according to me. All right. So with that, we can actually start looking at the R Studio environment. Okay. When it comes to big data, I think R is in the right place if you look at it, because R has decent integration with most of the new open source big data solutions like Hadoop, and there is immense excitement in the area of integration between R and Spark. Okay, Spark is another very popular, something which is really getting popular in-memory computing framework within big data space. I think, and it actually supports, R, and this is something really exciting. If you and going forward, I think this would become like one of the flagship areas where R would be used, or rather one of the most important areas where R would be used. And Microsoft has put R within Azure, is also making it available within Azure instances on its cloud. Now that is also that's also big data for you. Now, so it's going in the right direction. Now SAS is catching up. They have been sleeping for a while, but now they have actually started catching up. They are looking at integrating with Hadoop and all that. But I think R has a head start in that area. I wouldn't say it's more flexible, but it's kind of both these tools are from different. They started off with different use cases if you look at it. So if SAS, if you look at it, it has a more sequential nature. It resembles SQL more than anything else. R, if you look at it, the programming structure, the style, everything is very similar to a functional programming language. So it has different beginnings, but then I think they will converge in a couple of years down the line. Okay. Yes, data science is complex when it comes to, let's say, all that confusion, boils down to one thing. The requirements which are given to, let's say, the human resource department doesn't really get. I'm not sure. It gets messed up somewhere in the middle. The point is, data science involves, or rather, the expectation is that you are fully fit to work with multiple tools on multiple platforms. And so basically, if you ask me to quote some tools, I would say you need SQL, you need Excel, you need Excel in the sense like advanced Excel skills. You need R, you need SAS. You should also have some database skills as well. Now, in terms of tools, and these are ones. Big data. Well, if you are into that side of things as well, there are plenty of tools which you need, which you can learn there on that side as well. Okay. I hope I answered that question. Yes, there are a lot of requirements. Yes. So it's that you can have your favorites, of course. You can have your you can have that tool which you're really good at, but the point is it's good to be able to work with different tools, because you don't always get to choose what tools you can use within a project, because sometimes there are client requirements which doesn't allow you to work on certain things. All right. So this is your RStudio environment. Okay. Now let me quickly take you through. Let me quickly take you through all the different windows that you can see over here. Okay. Okay. If Pratik or Shweta, if you're listening, how are we doing on the time? When did we start? How much time do I have? Okay. All right. Continuing. I think I'll wait for them. Okay, I think I'll let them get back. So the screen that you see on the top left side is basically where you write your scripts within R, all right? And below you have this console, which is basically your REPL window, okay? Now, what do I mean by REPL? I can do something like this and instantly get the results, okay? I did 1 + 1 and 2, and it gave me the result that is 2, right? And here I can do 1 + 1, okay? Now that stays, which means this is a scripting window, so that's where I write my code, and that's how I can save my code, like for use later. Now, how do I run this? Control Enter. So basically, Control Enter runs a highlighted part on your scripting window or whatever is present on the current line. Okay, so I'm going to do Control Enter, and it ran 1 + 1, which is there in my script window, and it gave the result 2 again. So it's right here. So this is your REPL window. REPL window is useful when you're trying to, like when you need to, like quickly test something before you put it in your code, which is actually right here, which is your scripting window. All right. Now this is on the top right side, where I'm moving my cursor right now, that is your environment. Okay. So any R object that you create would show up here. Okay. So I mean this. So basically, when you're writing code, you can always see what objects are available in your environment. Okay. Now, files, plots, and packages. So basically, this is useful for checking a couple of things. You can always see what packages are installed. Now, packages are basically, you can imagine, like, so you want to do something extra, and so packages provide you extra functions to work with, extra functionality or functions. So if you remember, when I was asking you to download R from the R project website, yes, these are all the installed ones. They're not checkmarked because they're not loaded into the environment yet. So any package that you install would show up here. All right, so R gives you, that's one of the best things about R being an open source software. Anybody can write a package and make it available for others to use. Right, so you can always install new packages. What we have installed right now is basically R base, or base R. Okay, base R have all these packages, yes. It has a lot of packages, but then if you need something more, if you need, let's say if you want to run the random forest classifier, so which is like an advanced regression and classifier algorithm, right? So that wouldn't be there in your base R. So you need to install the random forest package for that, which will give you functions which you can use for running a random forest model, right? So I think I'm making it clear. I'm trying to keep it very simple so that people who are completely new can understand as well. All right. So those who already know a bit may not like the way I'm explaining it, but. And you can also see your plots and everything. And there's a helper tab as well, where let's say if you decide to look up the documents, it'll show up here, or you could access any of these documentation as well. If you click on it, it'll show up. You can always bring it up as well. Okay. All right. So that was IDE. We looked at REPL. So let me also show you how you can use the help feature. Say for example, if you know a function but not exactly sure how it works. Let's say for example the mean function. But you're not really sure. But this is a function which can give you keen interest in learning. That's the only prerequisite I can recommend. Not really, not really. So R has nothing to do with SQL at all. Definitely, it has all. It's heavy on stat functions and stat related stuff. but it also really good for data manipulation. But then, I mean, but it does data manipulation very differently from SQL. Okay, so let's say, for example, you have the mean function. There's a function called mean, but you're not really sure how it works, or maybe you're not sure what sort of arguments that function takes. All you have to do is, like put a question mark and then type the function name and run it. That is Control Enter, and you can see that the help page just opened up here. So click it to open up, and you can see that, okay, this is how it works. All right. So you can read about it. You can see what are the arguments. You can get a pretty decent idea how to work with it as well. I'm pretty sure they give you examples at the bottom of the documentation. All right. So that was like really quick intro to the RStudio environment, how to use it, what's what, and all that. And next thing is that we need to get a copy of okay, we would discuss how to import and export data. Okay, all right. So for that, I also need to get a fresh copy of the code. So you can actually follow this if you already know how to use Git. This will be useful for you. So I'm actually going to clone that repository. Okay, so it is within users. So I'll find a decent place where I can create a clone of it. Okay, all right. So go ahead, get the link from here. Just get a copy of the link, and come open up. So paste it in your command line window by typing git clone first. So this, and then the complete repository hyperlink or location. So this would actually, clone the entire repository onto my desktop. Okay, now I can go ahead and access it. And okay, so I already have the code on my disk now. Basically in my local environment. So I can go ahead and open it up. And this is how I can bring in, existing, code files or script files. So remember, they have a .r extension, R script files. I'm going to click on that. I'm going to navigate it to where I have created it. So airline filter assignment, there's a folder. I can go ahead and just click on it and open it. So there it is. So I already have, a working copy of whatever code that was there on the GitHub website. All right, so I have created. So there are some. So in case if you need my email, it is there in the code. In case if you have doubts, related to the code that is there in the script file, you can always contact me. That's my email. And all right, so we discussed earlier about, earlier we discussed about how we can install packages. Okay, this is a function that you use for installing new packages. It's called install.packages, and you give the name of the package within double quotes. All right. Now that can, help you install the packages. So all the package requirements are listed at the beginning of the file, so that it's easier for you to, set up your environment to, to work with it. All right. So I need to. Okay, I need to explain how the concept of working directory works. So you can think of working directory as a folder where you have all your data. Was there a question? Okay. So I need a folder where I can, put all my data and code together so that, like I can easily access it later on as well. So the concept of working directory is very similar to, I think there's a similar concept, there's a similar concept in SAS as well. But here how it works is because I already have a repository into a folder here. So all the code is right here, right? So I want to continue using that. So what do? I will just go and copy this location, okay, because this is where my code is. This is where I want. Oh, okay. Just in a minute. I'll get back to the code. So I'll just copy this location. I'll come back, and so this is where it is. What I'm going to do is I'm going to use this setWD function for setting up because you're in a Windows environment, you have to make sure that it is a double backslash. If it's Linux or Mac, all you need is a front slash like this, single one. Okay, so there are two functions that you need to remember. There's a function called getWD, which tells you where your current working directory is set to. Okay, and this says it's set to C user SNA documents. Okay, that's my document folder. Now I want to change it. For that, I will use setWD. Instead of get, I use setWD. And I've given the complete location, or rather the complete path, and I run it. And if I run getWD again, it is pointing to that folder which I have on my desktop, which was cloned earlier. Okay? And if you want to clear your console, just Control L. Now we have already set up our, the working folder. Now let's go ahead and get a copy of the dataset. Now let me quickly take you to what data that we're using here. So if you're not familiar with the Kaggle website, it's something you should really look at. This is where data scientists come to compete against each other. You have tons of data and problems to work with. Okay. Now there are plenty of data sets also available for working, practicing your data science skills. So if this is a one-stop shop for bettering your skills. Now, so make sure you get an account and download this Twitter US airline sentiment dataset. Okay, you can Google it. It'll take you to the link. All right, this is Twitter US airline sentiment dataset. So it's basically a dataset which has a lot of tweets recorded. Okay, and they've also classified the tweets based on the sentiment. Okay, the sentiment can be neutral, positive, or negative. Okay, so the travelers who have tweeted, about the airlines, and the efforts have been made to actually, classify each tweet as a positive, negative, or neutral. So that's the data set that you have. It's basically each row is a tweet. So let's get a copy of this. Just click on download data. Once you have access to it, you can do this later on. Absolutely fine. So I'm going to copy of it. It's a very small data set. The total size is around 2.56 MB. So get a copy of it. All right. Yeah. Okay. So that's done downloading. Let me go ahead and get a copy. I'm going to go paste it inside this folder itself, where we have already set, as our working directory. I'm going to create a new folder called data. Copy the data. The zip file there, and I'm going to extract the data. All right, so I've got the data now. I've got the data now. So the first one is basically a CSV file which has all the tweet, I mean, whatever data that we talked about earlier. And there is actually an SQLite version of it as well. Okay. Now, I'm not sure how many of you actually come across the SQLite database. So I have the main page open here. It's basically you know, a serverless. It's basically self-contained, serverless, no configuration required, transactional SQL database. So which means, what do you mean by serverless? So you don't need to install anything. There's no server. There's no standard version used for what? So self-contained. So basically, it doesn't really need a server or a server instance running. R can handle pretty much everything. It does have a small. I mean, it has small issues with importing you know, these spreadsheets, Excel spreadsheets with a lot of formatting. I think now that you know, Microsoft has a certain version of R. Yeah. It can work with XML. It can even you know, scrape data off HTML pages, anything. All right, so CSV is the preferred format. No, nothing like that. Text files, any kind of flat files is fine, absolutely fine. It can even load up the SAS datasets, like the SAS B. I mean, the SAS, you know, the dataset format, SAS 7B dat extension. All right. So coming back, so this is like a self-contained database, which is only a file basically. So what we saw here earlier was basically an SQLite file which is self-contained. All right. I'm not sure if I have installed you know, SQLite on this machine, because I definitely had it installed on my other machine, which I was planning to use. So we'll see if it works. We'll discuss it. If not, you know, for another day then. All right. So the first thing that we're going to do is import the tweet data from the CSV file first. Okay. How do we do that? It's pretty simple. You have to use the read.csv function. Okay. Now, what did I say about, you know, if you're not sure as to you know, how a certain function works? And you can always go put a question mark and give the function name and enter. So it opens up you know, all that you need to know. The documentation. All right. So so basically, read.csv is it's basically you know, a specific case of a more generic function called read.table. Now, read.table is used for, let's say, importing any kind of tabular data. So it could be. Yes, it is case sensitive. Yes, of course. So read.table can be used for importing any kind of tabular data. So if it's in a text file or a flat file, you can bring it in. There is some way of bringing it in. So there is read.csv, which is a specific case where, you know, the separator is a comma. Read.csv2 when you have like a semicolon. And there are two versions of read.dlim as well, where when you're actually working with tab separated data or TSV files. All right, where the separator is a tab. All right, so you can also make use of this function basically. You know, so RStudio gives you this feature where you can the import dataset feature. Go click on that. It opens up two options for you, like in a drop down. So you can even import you know, a data file from a URL link, you know, a web URL. So click on the from local file, and you can just navigate to the folder where you have the data, and you can just click on this CSV file and click open. It opens up this you know, this window for you, or this wizard sort of a thing. Now it gives you a lot of you know, things that you can change. All right, gives you a lot of control to change a lot of stuff. First thing is the name of the object which would hold the data once it's imported. All right, and the second thing is you can play around with the encoding, whether heading is so whether there's a header row or not. So which you can check the one which is relevant. Then you can change the separator. Of course, it supports stuff other than this as well, but you'll have to write your own code for that. So those are the main things basically. Just always uncheck the strings as factors, because it's because you don't want all your characters to get converted to a factor. So factor is basically a data structure within R. It will take a lot of time if I need to explain why, but generally when you import data set, just make sure you uncheck it. All right, so click import and it imports your data, right? You already have your data set. So it has loaded up the data and it is actually showing up like it's also visualizing the data for you right now. So these are the fields that you have: one trade ID, one airline sentiment. Basically, this is the sentiment column, and then you have some reason. You have a column where they tell you what reason people have given for giving a negative tweet, and then there's a column for which airline it is. There's a name column where I think it's for the user who have actually tweeted. There's a number of retweet. There's a column for number of retweets for the particular tweet, and there's the actual text for the tweet as well. Okay. Now this gives you what? So basically each of these each entry in this column is basically the tweet, the actual original tweet. Okay. And then you have the tweet created date as well. So there's one for coordinate. So I think if you scroll down, you could see. It's actually not very well populated. So I'm just explaining the ones which look fairly decently populated. So this would have like a latitude and longitude combo. Basically, tells you where the tweet originated. So this is the tweet created timestamp. So what time and date the tweet was done or made. The approximate location, it is not very clean. I've checked it already. It doesn't look very clean. So it's optional to whether use it or not. And there's a user time zone as well. Fine. Okay. Now, okay. So how do you remove? We use the rm command for removing, a particular object. So once we imported the data, it already showed up here, right? So this is what I said. Whatever objects that you have, it shows up in your environment. All right. Now I can use rm to get rid of objects. So it's gone. Now I'm going to use this command. I ran that command and I have the data back already. Okay. It's the same data. I just wanted a different name for the data. So this object, which holds tabular data within the R environment, that is called a data frame. Okay, it's one of the most commonly used data structure in R. There are plenty of other data structures, but this is the one that you can hold, tabular data. So anything that you import, any tabular data that you import from text files and all that, always gets saved as a data frame object. Okay. Now we have the data frame object. We'll come back to the SQLite part later. So let's go ahead and do some exploratory analysis. Okay. So just follow along. If there are things that you don't understand, you can always pop a question. Now the first thing that I want to do is basically I want to see which are the different levels. So I've clearly mentioned it here, the sentiment levels and their frequencies. So I want to understand how frequent and what are the different sentiments that's available, okay, in the data set, and how frequent are they. So for that, I've used the table function. The table function basically summarizes a certain column. Okay, so tweets is the actual name of the data frame that we have right here. The same thing. Okay, and how do I access a certain column? So I've shown you there's a column called airline sentiment. How do I access it? You use this small dollar operator. Okay, so tweets, dollar operator, airline sentiment is basically a column. Okay, Now I'm going to run the table function on it, and it already gave me the frequency and the different possible values. Okay, there's negative, neutral, and positive. Okay, the negative is basically the most frequent, 9,178, and the neutral is second, and the positive is right behind. So these are different, possible sentiment levels. Okay, now filter out the negative sentiments. Okay, now let's say I want to filter on this column. Okay, and I want to create a new data frame which only has negative sentiments. Okay, so this is how I'm going to do this. Okay, I would separate out all airline sentiment equal negative. Okay, so this is the syntax that I'll use for, and I'm going to assign it to a new object name, which is tweets underscore negative, which is the same name but an extension to it. So I'm going to run this. Sorry. And I'm going to open this. And you can see that almost all of so basically it's just a subset of the earlier data set with only negatives. Okay. Okay. The third thing, the most common reason for a negative comment. Okay. Now how do I do that? I've already shown you there is a column which says what is the reason for. Okay, I think we can use this one. This is better. What is the reason for actually giving a negative sentiment, right? The actual reasons. It could be a late flight or a bad flight. It could be a customer service issue. Now, how do I do that? So I can always run a table just like I did earlier, which will give me like a frequency distribution. And then I can sort it in the descending order and pick the first one. That gives me customer service issue. So which means customer service issue is the most common reason for giving a negative sentiment within your tweet. All right. And the next thing that we can try out is find the tweet which was retweeted the most. I mean the maximum number of times, right? I mean out of the negative sentiment ones. Was there a question? Okay, what is it? Can you repeat that? Sort helps in sorting the data. Okay, so table gives you what? Let me just break it down for you. Table tweets underscore negative $airline. You mean this one? Okay, all right. So the negative reason, right? So you do a table, and this is what you get. The frequency distribution of different possible levels within or reasons within negative reason column, right? Now, if you sort it with decreasing equals true, which is descending order, okay? So you want the most frequent reason to be on the top or first. So this gives you that. The customer service first, late flight second, can't tell is third, cancel flight is fourth. Now then I'm going to use this single number index. Okay. I need the first, so I'm going to use the first index of the system, which will only print out the first one. That's it. All right. Okay, the original idea was that you guys will have a copy of this so that you can try it out. But that's okay, you can do it later. No, not a problem at all. So, okay, all right, the next thing is, find the tweet which was retweeted the most, out of the negative sentiments ones. Okay, how do I do that? Which tweet was retweeted the most? So, of course, we have to start with, tweets negative $retweet count, correct? So there is a there is a field called that retweet, which gives you a number of retweets for each tweet. Okay, so I'm going to use a function, new function called which.max, which tells me which row or which element has the max out of this column. All right, and then I will just use that as an index within a data frame and print it out. Okay, so which is the reason for that is because I want, this is basically, you are actually using the square bracket for filtering a data frame. Okay, so data frame is a two-dimensional object. Okay, so it needs both rows and columns. Okay, whatever that comes before a comma is basically row based. So I am filtering on rows here. So it has to come before the comma. Anything that comes after, so let's say if I want to get a subset of columns, I would use the filter after the comma. So this only prints out the negative, the tweet, among tweets with negative sentiment, which is which was retweeted the maximum number of times. Okay, so it has just printed out the column. Okay, the row. It has actually printed out the entire row for which there is a tweet which was retweeted the maximum number of times. Okay, it's all. It has a negative sentiment associated with it as well. So that is the tweet which has, which is negative and retweeted the most. All right. So next thing that you can do, aggregate the sentiments for different airlines. Okay. Now, what if I want to understand, for each airline, what is, how many tweets were positive, negative, and let's say neutral, right? Now, this is the code for that. What I'm doing right here is I am actually taking a subset of the actual data set. And this subset would only have two columns. Now, so you see this comma here. Earlier, the row filtering was done in front of the comma. So the column filtering is getting done after the comma. Okay. So I'm choosing only two columns, and I'm creating a subset of tweets. Okay. Now, I'm sure a lot of people are new to R, and they might find it a little, like a little difficult to understand right now, but that's okay. That's okay. Follow along and try and understand what I'm trying to do here. Okay. So this is more of a, this session is more, it's actually to give you an idea as to what all things you can do and how do you actually, like manipulate data using R. Okay. It's for you to understand how you can work with data within R. Now you can take your time. The code is freely available. You can download it. You can use it, and the dataset is also freely available from Kaggle. And I want you to download them both and spend some time and learn. Okay. Now, if you don't completely understand something right now, it's absolutely fine. But if there is some gap in understanding what's happening, shoot a question. I can explain. All right. I hope that makes sense. But don't panic or worry if you're not really getting certain parts of it. But at least understand what I'm trying to do and what sort of results I'm getting, how I'm going about manipulating data within R. That's the key. All right. Okay, so I'm going to run this. All right. And I'll show you this new data frame that I created, sentiment_1. So that has airline and airline_sentiment. That's it. Just two rows. Okay. So basically, I used the tweets, the original data frame, and created a subset with only two columns. Okay. Now, this is the way you can add a new column. Okay. I need a column which is all 1, 1, 1, 1, 1. Okay. The entire all rows are 1. And how do I do that? So sentiment underscore 1 is basically a data frame, okay? And dollar count is how you would access a column, but the column is not present currently. But this is also the same, I mean, it's also the same way that you create a new one. All right. Now, I'm surprised nobody really asked me this question as to what this left arrow is. Okay, it's nothing legacy or anything, but it's more like yes, it does work like an equal to symbol, but then most traditional or most experienced programmers in R would actually use a left arrow. The reason being that's generally accepted as the standard. Yes, it means assigning a value to it. So it comes from the the old S+ days, but it's still being followed because that's how our programmers do it. It's more of a swag thing than anything else. Equal to works, yes, but generally people who use equal to within their code, for R, are generally looked down upon among people who code in R. So this is just it's more a swag thing. That's just a cool way of doing it. So you're free to not use it, but but bear in mind you will be judged, for not using it. I'm just laying it out on the table right now. All right. So let's come back. So I'm going to run this, and I'll show you what really happened. Okay. Now, so you have count. Okay, 1, 1, 1, 1, 1. So basically, I created a new column with that single step, and you have a third column right now. All right. Yeah, and so I've got 2 columns and a count right now. So why did I create that count? I mean, there's a reason for it. I'm fooling around. There's a reason why I created that count. So because I wanted to aggregate it. All right. So how does that work? Now there is a function called aggregate, which helps you aggregate values. So what are we really trying to do? I mean, let me just try and show you what we're trying to do. So in the airlines column you have the different airlines, right? Okay, and how do we see the different airlines? I'll show you. Dollar and the airline, and it says these are the different airlines, okay, in the data set. American, Delta, Southwest, US, Virgin America, everything. So I want to understand what is the count for each combination. So let's say one airline out of this and a particular sentiment. It could be neutral, positive, or negative. And what is the associated count? Okay, right now it's not aggregated, but that's what we're trying to do right now. Okay, I'm going to use the aggregate function, and the column that I need to aggregate is the first argument, which is the count. And how am I going to aggregate it? On a combination of these two, airline and sentiment. Okay, and that's given as the by argument. And sum is the function which I'll use for aggregating. Okay, it's the the aggregating function there. Okay, I could get a mean if I want. Okay, it could be a total sum. I mean, it could be any. So I can use different functions there. So I'm going to run this and show you what happens. So it created a new data frame, which is sentiment underscore aggregate, and I think it should be this one. Yeah, that's the one. So it's already aggregated now. Okay, the column names are a little messed up right now, but we can clean it up. That's not a problem. So it says America. Okay, it's not in the order. It's basically in the order of group 2. So how do we fix that? Okay, let's get the names in place right now. So this is the this function or this step would actually let me assign new names because it was messed up earlier. I've cleaned it up already. So the names function is used for getting the column names from a DataFrame object. Okay, so if I just run this part of it, so I'm highlighting this, running it. So airline, so it just returned the names. Okay. Now with this step, what I did earlier was, so earlier it was a little messed up. It was group 1, group 2, and all that. Now what I did with this step is I used this vector of characters, okay, character vector. And this is a character element, okay, and this 3-element vector, and assign this to the names of the data frame. So you can see that it's already cleaned up here, right? So let's try and so this doesn't really help us, you know, like because one American is here, the other American is right here. I mean, it's not in the order. So it would actually be helpful if, but this is in the order. So how do I change that? Now, this is what we can do. So this is how you sort things within a data frame in R. So you start with the data frame name, which is sentiment underscore aggregate dollar. Choose airline because that's how you want to sort it. So how are you going to do that? So what I'm going to do is I'm going to use this function called order. Okay, order. First, the first column by which I want to order it, and then the second one as well, which is the sentiment. So I want to aggregate. I mean, sorry, you know, like sort it on both. Then I'm going to use the name of the data frame again, and a comma because sorting is done on rows. Okay. Again, I need to assign the same thing. I mean, it's okay if you're not really completely getting it, but at least try and appreciate how, I mean, you know, how the manipulation is being done. You can take your time to understand later. So this is sentiment underscore aggregate. I've already sorted it. So let's go take a look at it. It's already clean, nice and clean, cleanly sorted now. So you have American, all of them together, and then you have negative, neutral, and positive in the same order throughout the data set, and you've got the sentiment count as well. Nice. This is what we wanted, right? Okay. So that's that. So let's move on to something a little more interesting. So this is basically okay. I'm going to introduce a new library or a package. It's called Ratio2. It's a purely data manipulation package. It can do a lot more than what's being listed here. I've just used one single function from that package. It's called dcast. All right. And so how do I load up a certain package? I use the require function. I use the require function and give the package name, and that gets loaded up. Oh, that's strange. I guess you get to see how things get installed as well then. So this is how you install a new package. Install by packages and your package name within double quotes. Enter. It should ideally work a lot faster than this. Okay. It automatically installs all the dependencies as well. So, but at least let me try and explain, you know, how this works. What I'm trying to do is, is it over? Okay. I'm going to use this dcast function on this, you know, sentiment.aggregate data frame that we created here, because I'm thinking it would look much better if we moved this column as rows. Okay, so you have negative, neutral, and positive as different separate columns. Okay, and airline as your first column, and you have all these values getting populated as cells within. Okay, that should be easier to visualize. I mean, that's how I feel. So I'm going to try and do that. But for that, I was planning to. I mean, it's possible to do it with base R, but the point is, I'm just trying to show off. So I'm going to use the dcast function and show you how you can utilize Reshape2 for you know, getting some manipulation done. And these are really powerful packages. Okay, most of them are implemented in C. By the way, if I haven't mentioned it, R is written in C. So the point is these are really, really fast. Okay, and it can handle really large data sets as well. I've generally heard a lot of people, talk about how R is not really fit for, let's say, large data sets. These are generally people who haven't really spent enough time trying to learn and understand R. Okay, R is, very well capable of handling really large data sets. Okay, and it has really good integration with, the big data side of technologies as well. Now, okay, it's taking fairly a lot of time. Generally, it's a lot fast. I do have like a 30 Mbps line here. I'm not really sure why it's taking a lot of time. Anyways, I guess we can come back to that, right? So, but let me try and explain this. By that time, I think if this gets over, we can come back and take a look at it. Now, so next thing is working with dates. Okay. Was there a question? Because in the original data set, let's go back. Okay, now everything is getting slow. We can even take a look at it. So there was a timestamp column, if you remember, right? So what do I mean by a timestamp? Hello? Am I audible? All right, great. I just got dropped out on my phone. Sorry. Okay, all right. So I was explaining, there are two ways of, like working with dates here. There are more ways of doing it, but these are the important ones. So basically, a POSIX CT helps you handle an entire data time, as in like date time object, and date as.date uses, can only handle the date part of things. Okay. Okay, so this is getting installed. So this is the date field, the date time field that we have. Okay, so let me quickly show you what I can do with these. Let me also show you, the reshape part of things. So reshape is now set up. I'm just going to go ahead and run this and show you what happens. So the aggregate wide part, so this is the new one. So see the difference. So this is what we had, okay? And so technically this is a long form data, right? And I've just moved it to wide form now, right? So this is the same data being represented two different ways. This is much more compact and easier to look at and understand. This is a lot. I mean, I don't know. It's just not easy to look at. All right, it's the same data, by the way. Okay, so coming back here, let me quickly run this. Okay, so I've tweet created one and tweet created day. Okay, and so let's go to the tweet dataset part of things, and there you have it. Okay, so this has the time part of it. I mean, both date and time, and the ask.date function pulled up only the date part of things. All right. So these are transformed from this field, basically. Okay. All right, going back. So further down, there are a couple of things that I've done here. The entire text mining part is still there. So I'm gonna try and move really quick through this. Okay. The general idea is we have this this tweet column, okay, where each record is a tweet. Okay. Now I want to clean it up. Basically, I can't use this. I want to create a model which can use this data to predict what sentiment it gives. Okay. That's what I want to do. So how do I play around with this? I need to clean this first. Get rid of all these hashtags. Get rid of all these punctuations, numbers, all that stuff. I want to clean it up. Am I audible? Okay. All right. So so I'm going to clean it up. I'm going to quickly clean it up. I'll take you really quick through the steps here. Okay, and so this is what I'm going to do. So this is how you define a function in R. Okay, this is the syntax for it. So this is the argument, this is the function name, and this is the function body where all the whatever manipulation happens, and this is what gets returned. Okay. Now I'm going to use this function, which is going to extract only those words, or rather, I'm going to use this to clear out all the hashtags from that. Okay. Now I'm going to run this part, which is text no tags. Which I'm going to use the tweets text column and use function on it and clean it up. So running it. And I've created a new column called text no tags. So let's just quickly, go and take a look at it. So this is what it is. Okay. So what said is the first one. So let's go take a look at the equivalent one. So there's one hashtag what, another hashtag said. This only has what said. It's already been cleaned up. Okay, but it still has a lot of punctuation, a lot of numbers, and a lot of other stuff. So we're going to clean each one of them. Okay. Remove punctuation, remove digit and numbers. Remove hyperlinks, remove leading and lagging white spaces. Okay, I'm going to run each of them one by one. And finally, convert everything to lowercase as well. So let's just go, take a look at that. Sorry. So everything's cleaned up now. No punctuations, no white spaces, none of that stuff. Okay. So that's cleaned up, and I'm going to use this TM package now. TM package is used for text mining and natural language processing in R. Okay, but I'm not going to really. Not again. I had all these things installed on my other machine. Okay, hopefully it doesn't take too much time. So basically, TM is used for both text mining and natural language processing within R. Okay, very useful, but I'm not really going to use any fancy functions. I'm just going to use the corpus function and the term document matrix function. It's just that I need to create. I need to get this data ready. Okay, for building a classification model. That is the that's the final thing that we're going to discuss. Okay, and I'm going to use a random forest classifier, and we can see how it works. So this is what it is. So half of the cleaning I've done is, in base R itself. This is all base R functions, gsub, toLower, everything. Okay, and here what I'm going to do is cleaning up tweets with TM, which means I'm going to remove stop words and remove white spaces which are within a sentence. Okay, stop words are commonly used words which have no use within text mining. So let's say it could be to a, the, and all that stuff. So I'm going to remove all those because there's no, I can't use them within, in my model building process. And I'm going to remove all the white spaces from within a sentence as well. Okay, so this is what I'm going to do. I'm going to create a corpus first. A corpus is all the tweets put together, all the words in all the tweets put together. That's a word corpus. Okay, and their relative frequencies. That is a word corpus, and I'm going to use that word corpus for creating, a matrix form which I can use for modeling later. Okay, sorry, need to load it up. So TM is loaded. Now I'll have the corpus function, and the tweets corpus is created. It's already done. Okay, now I'm gonna, on that corpus, I'm gonna clean all the stop words and the white spaces. That's also, okay, it's taking a bit of time. So you need to put them in a matrix form. I'll show you how we're going to do that. So you have the create term document. Okay, so this is where things get interesting. So till now, it is just a word corpus which is cleaned up and ready. Okay, now we're going to go ahead and build a term document matrix. Okay, I'll show you what it looks like once it's ready. So right now, so what we were using for this, we started off with a column which only has text, the tweets, right? So we started cleaning it up. Now we're going to create something really interesting. Now, I need, so basically the fine frequency terms gives me what? It gives me, all those terms which have a relative frequency more than 200, which means there are fairly frequent terms within, within the data set, the tweet data set. Okay, so I'm going to run that. So that is what I'll use as my features. Okay, now I'll show you what that is. Let me just create it into a data frame first, then I can easily show you. Okay, I think that's done. So that is tweets underscore DTM, and let me just pull it up. Okay. Let me try this again. Okay, so this is how your data would look like. Okay, so this is the data that you can use for, let's say, building a model which can classify sentiment. So from tweets, what we have done is we extracted words which are relatively frequent within tweets, and each tweet, so each line represents a tweet. Okay, and these ones and twos are number of times these words repeat within a tweet. And this model is called so this way of representing data is called bag of words representation. This is what you can use for actually working with text data for building models. Okay. Now what you need to do is use this data and try and build a classification model which can predict, given a new tweet, the model should be able to tell you what sentiment is associated with it. Okay. Okay. I think I'll have to install the Carrot package as well. What's the status on the time? I think I've overshot the allocated time by a huge margin already. So Carrot package is, it is a very useful package when it comes to data modeling. I think it's fairly I think it's fair to say that it's one of the most used packages when it comes to machine learning in R. It has a function for almost everything that you can imagine or that you would be doing within the in the context of let's say machine learning and data mining, because it helps you. It has a function for different kinds of pre-processing, feature selection, model building. It has something for grid search, for hyperparameter searching. I mean, you name it, everything is there. One of the most useful packages. There are plenty of videos out there. And it's very useful. And in the context of this this script, I've used it for creating two separate partitions, basically, of the data that we have. And one is, so basically that's called the holdout method. So you basically use the holdout method for creating two separate sets of your data so that it's easy for you to, build and validate your models. I mean, basically helps you to, make sure that your model is valid or it's good. Carrot does have a lot of dependencies, so I mean, it's going to run for a while, I guess. I mean, so with Carrot, I would create two separate partitions and use one of those partitions, which I call as train, within the random forest classifier, and start running the model. Okay, finally. Thank you. Okay, so let's load up Carrot and see what we can. And where did you see it? List equals false. Right here. That is for that's basically it's for your output basically. So your output is something that you're using within a data frame as an index. So you don't want it to be a list. You want it to be a numeric vector so that you can easily use that for for sampling out your data. So if you put it as true, it will return a different kind of object. You can try that. Now I just created two new data sets, basically by dividing the actual data set into two parts. One having 70% of the data, which is train, and the test part of it, which has 30%, the rest of it. So we will use the train part of things for training the model. Okay, so we're going to go ahead, and I really hope random forest is installed. It's not. I don't use this machine for development much, which is one of the reasons why I don't have most of these things installed. But random forests should get installed pretty fast. Okay, so I'm going to set the seed, and I'm going to import the random forest package. It's already ready. Okay. And I'm gonna use a formula object. Okay. Now I'm gonna give you like the easiest explanation for a formula object. R understands something called formula, and these formulas are are a means of making R understand what are you trying to model. So we are trying to model sentiments. Okay. We want to build a model which can predict sentiments. Given a new tweet in the form of that matrix that we saw earlier, it should tell you what the sentiment is. Okay. Now that's what we're trying to do. So it's we're trying to tell the model that it is sentiments that is what we're trying to model, and because it's on the left hand side, and on the right hand side it says a dot, which means all the columns available should be used. It's a notation which means all the columns. So I'm going to try and reduce the number of trees because I want this to run really fast. I'm going to put it as 100. And so basically, random forest is a technique. It's actually an ensemble technique. Okay, so I'm sure, I mean, a lot of you would have heard of distant tree methods and all that. Now, this is something way more complex, but much more effective. The reason being, it takes an aggregation of trees to build a model, which can be a lot more accurate than a single tree-based model. Okay, so n tree equals 100 mean I'm going to use like I'm going to make it a little more smaller. I'm just going to say 50. Okay, this is not ideal. The default size is 300. But I'm, in the interest of time, I'm just going to keep it as 50 for now. Now, mtry 36 is so based on the random forest algorithm. I'm just going to run this first, and then I guess we can just I can explain the rest. Typos. Then I will let you go. Okay, so the random forest is actually started building its model now. What you see here is 1, 2, 3 represents the different classes. Okay, and these numbers that you see, 27%, 53, 53 are basically the error percentage for each different column. Slightly high if you look at it, but the reason being we're just using just 50 trees. You can improve the accuracies by, of course, bringing in more. We're only using around what 107 features. You could always bring in more features. You could have more trees. You could tune up your mtry. You could play around with sample size. There are a lot of things you can do for improving your model. So this is just a dry run if you look at it. And so here, like I said, mtry is basically the number of columns, okay, out of this 107 that we have, which will be used at each tree building step. Okay, so it's really beyond the scope of this session to explain the random forest algorithm per se. But the point is, you can tune this mtry for getting better predictions. Okay, mtry is the number of columns considered per like tree building step. Okay, so that part is done. So this is your random forest model. Okay, that is your model object basically. It has a lot of things within which could be of interest to. So it has. That's only for, let's say, making sure that these variable importances are computed. Okay, so it gives you a lot of information. So basically, this RF tree object have a lot of information within. And one of the things that can be really interesting is basically after the tree is built, you can just go ahead and take a look at what they call as the importance. Run this, and this gives you like a matrix which has the importance of each word that we used in the model based on two different metrics. One is mean decrease Gini and mean decrease in accuracy as well. So this tells you, so this could be used for computing how useful a certain word is within your modeling process. Okay, so I mean, similarly, it gives you a lot of information that you can play with. Okay, now how do I go ahead and predict? So that's the last step. Even for that, I need a new package, which is matrix. But this is a fairly small package. It should get installed really fast. Okay. Now that, okay, so how do I predict? I'm going to use this RF tree, okay? And this is the predict function. And this is the RF tree, which is the model that you've built. So I'll use a predict function, put the model tree inside. Test underscore TW is the data that we kept aside. So we test our model, right? So I'm going to go ahead and make a prediction. And the predictions are saved into preds. That is just an object which has all these information. So it's already done. Okay? So the prediction has already been made. And the result is what? This. So I'm going to create a new data frame which has both the original, the sentiments from test and the predicted ones as well. So you create that so that it's easier for us to like visualize it. It won't look really, it might look, some of them might be wrong, some of them might be correct. I think fairly okay. If I remember correctly, this should give you around close to 70% accuracy. I mean, this is just a dry run, and even that is getting you close to 70, which is pretty decent. And if you go over a couple of iterations and play around with more words and all that, it should definitely get you to a decent accuracy predictor. Now, what I'm going to do is I'm going to run this. So this CE is basically a function which is available from the metrics package, which gives you classification error. Sorry, I think I didn't. Okay, so this gives you the error percentage. So which means 31.7% error, which means I think we're close to 70% accuracy. It should be around 68 point something. Okay, so this is just a dry run. We already really, very close to 70%. Couple of iterations, if we could bring it somewhere close to 90%, it should be a very, very decent model. Now, let me sum it up for you. We had a tweet column. We cleaned it. We split it up into different words. We built a bag of words model of representation and used that for, creating a model which can predict the sentiment for a tweet. So all you have to do is, when you get a new tweet, split it up into, different words and get it in the same form as the bag of words model. Okay, and then use that for for getting, and use the model that you've built for predicting. And the model can actually give you a sentiment which you could associate with that tweet. And it's completely automated. So, and if you could build a model which is slightly more accurate than this, it should be a really decent one. All right. So I think with that we come to the end of the session. Okay, there were a lot of questions. Before I could read it, just popped out. How to learn these codes and syntaxes, which to use when? There can be many such codes to know those. Yeah, if you look at it, there are a couple of ways. Whatever you're trying to do, there are a couple of ways you can do it. Like I said earlier, I said I could do, the reshape 2 part of things. I said I can code this dcast, what this dcast function is doing within base R. But this is much easier because it's just a function. I can do a lot of stuff. Okay, I mean, if I write this in base R, it's going to take up at least a couple of lines. But yeah, there are different ways of doing it. Using packages are pretty, I mean, not all packages are good. I mean, if it's a good package, then you can use it, of course. But there are people who always like to write stuff in base R, saying that, package dependencies doesn't really affect the code. I mean, that's different. That's a completely different thing. But you're right. There are different ways of doing the same thing. How to learn this? Well, it takes a bit of time. The syntax might look, I mean, if you're new to R, I mean, this whole code should look really, really, really intimidating. I understand that, but the point was to give you a real flavor of what you can do with R, okay, not just some toy stuff. Okay, so these are stuff that you can really do. Okay, these are stuff that you would, if you get into a position where you are working on text mining problems, these are stuff that you would actually do. And believe me, the TM package there's a lot more stuff that you can work with. I mean, I've just touched like the tip of the iceberg, if you can call the TM package as an iceberg. Yes, it takes time. Yes. So what percentage of actors should we accept? Oh, there's nothing like that. There's no thumb rule for that. It all depends on what area you're working on. In certain applications, you might be okay with, let's say, but the general thumb rule is, I mean, there's no thumb rule basically. I mean, it's always about the best model that you can build. And if you can't, I mean, if you're not able to build something which has a decent accuracy, you could always go back and start, collecting more data, or maybe looking at it from a different perspective altogether. I mean, it's always, but then again, there's no thumb rule if that's what you were getting at. It depends on what field and what the application is. I think then we should have to remodel. There's no remodeling. I've used only 107 out of. I've used only most frequent words. I could always use more words. That itself will pull up the frequent. I mean, the predictive accuracy. And plus, I haven't optimized the model yet. There are a lot of other things that you need to do to make sure that you are using the best parameters possible. And you can I mean, the model tuning step has not been done. So once you have, once you include more data, and if you tune the model properly, it's going to go up considerably. Believe me, 90 plus is possible with this data. All right. Is there more questions? This is really interesting. I mean, so in the sense, like machine learning is really, really, really interesting. Once, I mean, it's intimidating when you start, but once you get the hang of it, it's one of the most coolest things that you can do. Of course, yes. Yeah, I code in both. I use Python as well. At work and for personal stuff as well. I really don't like comparing both of them because they're completely different. If there are people out there trying to compare it, I think they're wasting their time. They're both exceptionally good for building models, and they both have their pros and cons. And if you're hell bent on comparing it, please remember it's just apple versus oranges. The part where both can be used for machine learning is, it's similar to, you can eat both, very tasty, very useful, but very nutritious. But don't try to compare it. Just eat it. Just use it. Any other questions?
right. I think a lot of good questions. Hey Shoaib, it was a very informative session. Hey guys, sorry it took a little bit extra time, but I did not start just because Shoaib was in the flow and a lot of people were asking good questions. But Shoaib, thanks a lot. I know it's a little late in the night, but it was really an interesting session. I think you did a phenomenal job of creating the right level of interest in these folks. And hey guys, as I said in one of my earlier messages, please feel free to reach out to us. Uh, uh, for any help on learning any of data science technologies or data science as a whole, we'll be more than happy to assist you in any manner. Plus, if you want to get connected with Shoaib as well, you can reach out to us. I've left our central email ID on the chat message. Feel free to reach out. Shoaib, anything else that you would like to end at the end?
I mean, I think you touched upon the fact that we did take extra time. I mean, and I want to thank people for like still being online and listening to it, even though we took more time.
Well, not just
So thanks
listening,
for
they were
that. I mean, I
participating
think
also.
exactly, yeah. And the questions were actually good. I mean, I enjoyed answering those as well. I mean, those were actually very good questions. So yeah, I mean, all in all, it was good for me. It's just that we could have managed the time better. That's all.
All right.
But good audience. I mean, really, I mean, thanks a lot for listening in and being, I mean, being part of it. Thanks.
Thank you, everyone. Have a good night. Take care. You can, by the way, see the recording of this webinar in a couple of days on our YouTube channel. Okay. Take care.
Okay, thanks everyone.
Bye bye, Shoaib. Good night.